Okay, so this is problem 17 of chapter 10 of Giancoli 6th edition. So we have a house at the bottom of a hill, which is fed by a full tank of water with a certain depth. Okay, so let me try to make a drawing here. Down here, down this hill, we have this house. On top of this hill, we have a tank. And we have the depth of this tank is given to us. I'll call it D. Okay. And this house is connected by a pipe, and what is also given to us is this length of this pipe. Okay, all right. They also give us this angle here. I'll call it this angle theta. So D, L, and the angle theta are given to us. And well, they tell us neglect turbulence, frictional, and viscous force. And the first question is determine the water gauge pressure at the house. So remember what gauge is. No, gauge pressure is the pressure only caused by this water and not by the atmospheric pressure on top of it. No? So we don't want the absolute pressure, we just want the gauge pressure. Okay, so how are we going to get to that? Since we just want the gauge pressure, I want the difference in pressure between this top here, where I just have the atmospheric pressure, and this bottom here. So I want this P2 minus P1. This is the atmospheric, the gauge pressure without taking into account the atmospheric pressure. And what is this value? Well, it will depend on the density of water. The density of water at 4 Celsius, we know, is just 1 gram by cubic centimeter, which is 10 to 3 kilogram by cubic meter, multiplied by G, and multiplied by the height. Now, what is the height? The height is this whole part from the surface of the tank and where the house is. So this is the height. Okay, so to get to this height, what we have to include is that depth of the tank plus this height of the hill. And the height of the hill, we have to play with this triangle here, right? So we have the angle, this angle theta, we have the L is the hypotenuse, so I can get this height of the hill. Okay, so then we are done with this first question, which is, what is this gauge pressure? The second question is, how high would the water shoot if it came vertically out of a broken pipe in front of the house? Okay, so the question is the following. Here at the bottom of the house, where this pipe is, what do we have? The water here is suffering a force, a layer of water here has a force pointing down caused by this total pressure, the gauge pressure plus the atmospheric pressure, which is being held by the same force pointing up. Now, this is the situation of equilibrium. Now, if we make a hole at this point, so this force here is not being exerted anymore, there is no column of water holding exerting a force down anymore. So we'll just have this force up, and this force up will be able to bring this water all the way up to the initial height. Okay, if we ignore viscous effects, if we ignore any frictional effect, then this force will be able to bring this object all the way up again. So the height will be again the D plus the height of the hill.